As I say, the point behind these is not to spend ages covering every mathematical function. There's a lot of thought into Excel, as we can see, and to go through each one isn't relevant as such. And we've seen a fair share of them. Certain ones that are very common, certain ones that we use quite frequently are worth looking at. And there's a couple in here that I think is worth looking at. Let's have a look at the value 10.2. So if we look at the value 10.2, if I wanted to, I might want to round up or round down that value. So one way of doing this is to use the command round down. Then if I take this value here, then, I've forgotten to put the number at the end. I need to tell it how many digits I want it to have. So let's just put 0, just for now. Close the brackets. And we can see that when it talks about digits, we're talking about decimal places. So it's rounded it down to the nearest decimal place. Now, if we take the same thing, but we use its opposite counterpart, round up, and we've got number of digits again, so there, and we're going to go for 0, then that's rounding up to 11. And you can see, though it's 10.2, any fractional part above 10 will cause round up to round up. And similarly, it doesn't matter if we took this above 5, the rules of mathematics are not applying to round down. Round down just rounds down to the nearest fractional point of there. If we took this value and put 10.64, then again, if we change this value here to 1, it goes to 1 decimal place. And same thing here to 1 decimal place. So we can now see that it's rounding to 1 decimal place. So this is going to 10.6 and this is to 10.7. There is a function called round. And if we use round, then we can click on our value. Again, tell it the number of places. I'm going to put 1 so we can keep it in line with the others. And we can see that it will go to 10.6, just like round down. But if we take that to 6.65, it then rounds up. So this is what we would expect to see in mathematics. So you have all 3 available options for you. There are a couple of others. So we can see them in the maths part here, ceiling math, and then we should have one here called floor math. So let's have a look. Equals ceiling.math. This is the new function. You can see there was one that's been deprecated from the system. So we're going to take this value here, close it, and then press enter, and we can see that that takes us to 11. We can also have floor dot, need the equal sign, otherwise nothing's going to work, equals floor dot, and you can see that symbol, by the way, telling us that floor itself is deprecated, which means it's not going to always exist. So we get used to the new one, take the same number, and then we close it, and we can then press enter. Now you might ask a question, well, what's the difference between these and these? Well, this is significant places. So I could say to 1 significant place, and we get 11 coming up on the ceiling. What if I say 2 significant places, and I get taken up by 2 points? So what it's doing is this is working out the gap, the multiple by which we're looking at. Under mode, we've got another decision to make, and that only decision is what happens when we get near to 0. So if we're a negative value, the decision with mode is, do we move nearer or away from 0? So the mode argument, it doesn't affect positive values, but what it does do is move it up towards 0 or away from it. So that's worth noting, but rarely used. This significance is a multiple, so it's 2's in multiples, so that will be 2, 4, 6, 8. Since this is 10.65, the next multiple up from that, because it's ceiling, is 12, because it's going for that gap. For example, if I change that to a 5, then the numbers it will be looking at is 5 or 10 or 15. So if we accepted that, in fact, let's choose 7 because that's going to affect our number below. So 7, 14. So this should come back 14, which it does. If we then do the same thing here with 7, though it's 10.65, the nearest floor to that is 7 itself. So it's using that second number as the nearest multiple you want. So if you wanted it to the nearest 10, you could do so, or the nearest 100, or whatever else you needed. And that will do those values. So you've got ceilings and floors, you've got round downs, you've got round ups, and you've got rounds. Now, the interesting thing here is, of course, we've got the ceiling and we've got the floor. Here, in a way, the floor is very similar to our round down and our ceiling is very similar to our round up, but we've got a round. You may have seen when I was doing round that there's something called M round. M round works very, very similar to these, in that if we take this value and we then say 7, it will take it to 14. But if I take this value nearer to 7, let's make it 8.6, then it will round down. So that does exactly what we're expecting it to do. This is basically for these two what round is to those two. So we've got a number of tools available for us there. Okay, hope that was useful. See you in the next lesson.